So this is the final design for my final project in this class. It's a music synthesizer that has a oscillator that's basically generate different types of waveform at different frequency, depends on the user input. And it also have a low frequency oscillator which typically generate a frequency less than 20 Hz. So the input circuit has a 7 push button that represents 7 notes that the user can play with. And this is configured so that every time a push button is pressed, it will has a voltage that apply to the input of this voltage to frequency converter. The output of the voltage to frequency converter is a square wave with the frequency proportional to the applied input voltage. So if this put button produce a 1 volt output, then this converter will produce a 100 Hz output square wave. And the output of this converter is go to this op amp, which is a integrator that will produce a triangle wave when the applied input voltage is a square wave. And this IC here is configured so that it will produce a triangle wave and a square wave at a much lower frequency. It can produce a frequency from 2 to 18 Hz in this circuit. To change the frequency, we can just turn in this potentiometer here, and it will either increase or decrease in the output frequency. So this oscillator circuit here had a 4 output that go to this dip switch. The 4 output is square wave, triangle wave, low frequency triangle wave, and low frequency square wave. And we can set the dip switch here that will output to the mixer. And so right now, let's turn the square wave on and play a note. So that's how the square wave sound like, and this is the output waveform. Now I can just change it to triangle wave. Now I can add the triangle wave with the low frequency square wave. I can also add the square wave to this low frequency square wave. And I can also add the high frequency square wave with the low frequency square wave and triangle wave. So the sound of each combination is a little bit different from each other. So that's the output of the oscillator. So right now I have it configured so that the output of the mixer directly goes straight to the inputs of the voltage control amplifier stage right now. So can go over the output stage, which is configured so that it will alter the volume when we adjust in this potentiometer here. So it had another op amp which is configured as a inverting amplifier, which basically scale down the input voltage that the mixer produce to another factor of 5 to produce the input voltage, and then this output voltage from the op amp is go to this long tail pair with the current meter. That's and this potentiometer will control how much of the current that the current meter produce. And right here, and this op amp is basically just a difference amplifier. It just cancels out the common mode output voltage and amplify the difference between the two outputs of the long tail pair. So right now, if I adjust in the volume, you will see like how the amplitude is getting smaller. I just turn it down, go it up right now. Okay. So that is the output stage. So right now, I would turn this one off, which is like remove the direct connection from the mixer, so and configure so that the output of the mixer then go to this filter and see how it sounds like. So right, the filter has a high pass, low pass, and band pass filter. So I'm gonna turn on the low pass filter. This filter using the Allen key topology, the silent key topology, and it had a cutoff frequency of 100 to 800 Hz for the low pass filter. Turn the volume up a little. Turn this one down. This is at the low end of the cutoff frequency, and now I'm going to change it slowly to the high end of the cutoff frequency. Yeah, this is the maximum. Now I'm going to turn on the high pass filter and see how it sounds like. The high pass filter have a cutoff frequency from 100 to I think 400 Hz that I measure. It will alter the sound as the cutoff frequency is changing. And that's for the high pass filter. Now I'm going to turn on the band pass filter. This is at the high end of the band pass filter. Now this is at the low end. It had a really low volume at the low end. So yeah, so that's yeah, so that's how the sound changes when we pass in the signal to the low pass, high pass, and high pass filter, and that's pretty much the design. So I think like the use, so we can place like a lot of cool stuff with this by just altering the sound and maybe play some song. Let's try with the low pass. Just one more thing to mention that there's a pulse that the speaker is producing right now, like every 1 second, and that's due to the 100 millivolt offset voltage that this converter is producing. So as you can see on the screen here, we see like a pulse every 1 second. That is not like desired. That's to have the pulse like this with no input apply. But other than that, I think it's pretty good when we play with different notes or like different types of waveform that apply to the circuit or which filter we use, and then it totally affect the sound that we hear. And yeah, and that's it for my final project.